Hello and welcome to my today's lecture on an overview of electric drive unit, EDU and its components. This webinar is being organized by Great Learning for PG program in electric vehicle design. So the contents of today's lecture is nothing but what is the main problem, why do we need to shift, what is the main problem, why do we need to shift for electric vehicles, or why do we need to take a switch over for electric vehicles, and what is the overview of the topic for today, and what are the components. If you look at the components, what are the various components like switching devices and power converters, what are the various machines, electric machines, like what are the various electric machines, like types of electric motors. Okay, and we will also have a case study with a MATLAB simulation and a practical setup, and we will also have a discussion on the career paths, jobs and roles and responsibilities. So to begin with, the main problem is nothing but the CO2 emission. CO2 emission is a main problem, and all the countries which are developed, which are already developed, all the countries which are already developed and which are still developing, they want to become CO2 free. Even India has also taken up an initiation to go for CO2 free emissions by certain deadlines. So CO2 is the main problem for engine vehicles. So the replacement of the engine vehicles to get rid of CO2 is nothing but, the answer to this is electric vehicles or electric drive units. So let's internal combustion engine, comparison between the internal combustion engine and the electric motors. So what is the basic comparison? So for example, if you look at the internal combustion engine, it has got various mechanical aspects. Mainly the mechanical engineers deal with the mechanical movements and the mechanical reactions that are taking place due to certain rotating rotating mechanical mechanisms inside an engine. Whereas if you look at the other side, which is nothing but electric motors, this deals with mostly the people, they deal this is the area where electrical engineers look into it. Like these are nothing but the motors. This is basically the motors. Motors also have the electrical part. That means they convert the electrical energy into mechanical energy. So what is the difference between the engine? The engine gives the rotating mechanical energy, whereas motor also gives the rotating mechanical energy, but the input to the motor is electrical. So that is the difference that makes motors more superior over engines, because to an engine the input comes through a fuel, that is nothing but a chemical energy, and the output goes as the rotating mechanical energy, because we know from law of conservation of energy, energy can neither be created nor be destroyed, but can be transformed from one form to another form. So that is the reason what happens over here is, being an engine, it has one input and it has one particular output of an engine and output of a motor basically is the same. That is nothing but rotating mechanical energy. Here also we get rotating mechanical energy, but the input to this is nothing but electrical energy to the motor, whereas input to this is nothing but the chemical energy that comes from the fuel. So to proceed ahead, let's see a basic overview example of this one. If you look at this example, there is a switch. First, let us look at this. What do we mean by SW1? This is switch 1, whereas this is a motor. Okay, so this is a switch. So let me take my cursor. Okay, yeah, this is my cursor. You can see that this is a switch, this is a motor, and there is also one more transistor that is grounded. Okay, this arrow mark indicates it is nothing but, we'll talk about the switches later, but as if now let us look at it in a very basic overview manner, because I'm just trying to explain you a simple example of electric drive unit. So what is an example of electric drive unit? When we talk about an electric drive unit, it has some battery, it has a switch, it has one more switch, and it has a motor. Okay, let's talk in simple words. As when we talk about a simple EDU, it has a battery, it has a switch, it has a motor. So that means if you look at this, If you look at this, the major concerns are, this is my battery, this is my switch, and this is my motor. So what is going as an input here is nothing but it's called as an electrical energy, and what is coming out over here, that is rotating in nature of the motor, which is the output, that is called as the mechanical energy. Now if we compare this circuit with a theoretical aspect to a practical scenario, we can see this. What is this? This is nothing but a switch that is getting on and off. You can see that when this gets on, the conduction path is provided and the motor rotates. As a result, when the switch is on, the motor rotates and it converts the electrical energy into the mechanical energy. So this is just a simple illustration of a basic electric drive unit that can be constituted or constructed with the help of a battery, switch, electronic switch. When I mean by a switch, it is not a mechanical switch, an electronical or electrical switch, and motor. So this combination can drive the vehicle without any fuel, but only with electrical batteries. So that is the reason we are here today. So to overcome the mechanical losses, to overcome CO2 emissions, to overcome the fuel prices, the increasing prices, petrol and diesel prices, we want to replace them all and solve this problem of rising rates, rising prices, solve this problem of rising prices, fuel consumption and CO2 emission issues by using a simple EDU, by using electric drive units, rather than saying simple EDUs, by using electric drive units. Now the more elements you add, the more precise motors you take, the more complex the system becomes. That means it no longer remains a simple EDU. It becomes a complex EDU. So we will talk about it later. But as if now I wanted you people to understand what is an EDU is. So in short, an EDU is, it has a battery, it has a switch, it has a motor. And now I'm going to talk something related to a power switch. So what do you mean by a switch? So when you look at a switch, if you look at a switch, it has only two conditions. As if now, let us take two ideal conditions of a switch: when the switch is open or when the switch is closed. Okay, let's say the switch is closed. Either the switch is open, which is the first condition, and let's say either the switch is closed. Let's take the first condition, which is nothing but the switch is open. Second condition, the switch is closed. So when it is open, in electrical terminology, it is being termed as, in electrical technology, it is being termed as nothing but open circuit. In electrical terminology, when the switch is open, it is called as open circuit. When it is closed, it is called as a short circuit. So we know Ohm's law. What is Ohm's law? Ohm's law is nothing but V is equal to IZ, where I stands for current, V stands for voltage, Z stands for impedance. So when we talk about voltage, what is voltage? Is the difference in charge between 2 points. There is some difference in charge between 2 points, it is voltage. And current is a flow of charge through a wire per second, or you can say that number of charges flowing per second. And what is the impedance? Is the opposition to the flow of current, so offered by the circuit. So let's talk about what do we mean by when this is open circuit. What happens? This is open circuit, the charge cannot flow from here to here. So charge cannot flow. So when the charge cannot flow from here to here, what happens is, it is open. It is open. When it is open, if the charge cannot flow, the current is zero. What is charge? Charge means current. Flow of charge per second is nothing but electric current. So when it cannot flow, the current becomes zero. If current is zero in this, what about Z? Z becomes infinity. So that means the opposition offered to the flow of current is infinite. In this case, let us to be noted that. Then let us go to the second one. If you talk about the second switch, if you look at the second switch, it is second condition. Let's talk about the second condition. If you look at the second condition, it is a short circuit switch. Now the current can flow from here to here. It can flow from here to here. That means not zero. What is zero over here? Since it is shorted, these two terminals are shorted, there is no difference in charge between these 2 points. The same charge flows from here to here. So the voltage between these 2 points is zero. That is nothing but voltage in short circuit is zero. Okay. So as a result, the impedance becomes zero. Z value becomes zero indirectly. Z value becomes Sorry, I think I wrote infinity over here. Let me erase that. Z value becomes, Z value becomes, Z value becomes, just a second, Z value becomes 0. So clearly, and an indication over here, what have we got is nothing but we have got the value of Z changing from 0 to infinity. That means I can control the switch either totally short circuit, or I can control the switch totally open circuit. Totally open circuit. That means Z values are in range of 0 to infinity. So I just talked about 0 condition, I just spoke about infinity condition. Now my question is, what if we control the value of Z from 0 to infinity? That means in between the values of 0 and infinity. Yes, that is also possible by employing certain control systems. By employing, yes, that is possible by employing or by modeling a controller. By modeling a controller, there goes, by modeling a controller, there is a need for a control system, or in other words, a simple controller that can control the values of Z, or that can control the percentage conduction of the switch, that can control the percentage conduction of the switch up to certain instants, not only just I is equal to 0 or I is equal to infinity, okay, or not only for Z is equal to 0 or Z is equal to infinity, it can control from 0 to infinity. So you can design it in that way. So there is a need for control system. Instead of, when we go for more complex systems, as I said, here is only one switch, here in this case we have only one switch. When we go for multiple switches, there is a need for us, not only for multiple switches, even for single switch, there is a need for us to design the value of Z from 0 to infinity. So as per the requirement, we need to control the switch so that we can control the action of the motor. So this is the basic idea, which can be modulated into more complex steps further, but this idea can be elaborated using a concept called as power electronics, and mind it, this is not a simple switch that I have discussed. For consideration purpose, for explanation purpose, I have just shown this as a simple switch. So the switches in power electronics or in electrical engineering side could be of three categories. What are they? Let us look at them now. See, they are nothing but of three categories. Number one, the first type is called as uncontrollable switch. This is the first one. This is nothing but uncontrollable switch. Then second one is nothing but partially controllable switch. You can on them, but you cannot off them. Then you go to the next one. There's something called as on and off, fully controlled. So that is something like you can on them, you can off them as per your wish. So switches in electrical engineering or in power electronics usually are of three categories. Number one, the first one is called as uncontrollable switch. You cannot control it. Second one, partially controllable. Third one is fully controllable. That means partially controllable means you can make it on, but you cannot make it off. Third one, you can make them on and off as per the requirement. For example, you look at a transistor, there is one, it is called as a fully controllable. So transistor is nothing but, this is emitter, the arrow indicates emitter, this is base, this is collector. Okay, so whenever you give some value of current to its base, let us say I is not equal to 0, let's say I is equal to 2 amps. Let us say if you give this becomes on. If you don't give I is equal to 2, let's say you give I is equal to 0 amps. If you give I is equal to 0 amps, then this becomes off. So that means it depends on the value of current. If whatever the current you are giving to the base, that drives the switch either in an on state or an off state. So what I'm trying to tell you is, we have got different categories of switches. Okay, we might talk about this in detail later on, but as if now, remember that SCR, silicon control rectifier, or thyristor, you can make it on but you cannot make it off. There are other provisions that you need to use to make it off once it is on. So those are nothing but commutation circuits of SCR. So we will see that the point of discussion over here is just to understand an uncontrolled switch, partially controlled switch, and fully controlled switch. The idea is that. So what I'm trying to tell you is, what if I replace this switch here with uncontrolled switch, with some partially controlled switch or with fully controlled switch. That is my idea over there. So you can model the system in that way and you can get the complete aspects and knowledge out of it. Okay, so let me go to the next slide, which indicates what type of different power conversions we have. But before we go to this, I need to remind you that when we deal with electrical engineering, all mechanical people can understand this aspect. Whenever we are dealing with electrical engineering, we need to understand that power is of two types. I mean, the electric power is of two types. Basically, I'm not talking about the mechanical power. I'm talking about the electrical power. Electrical power is of two types. It is AC and DC power. When we talk about AC, it is purely a sine wave. Okay, when we talk about DC, it is a constant voltage that is constant with respect to time. A quantity that remains same with respect to time is DC. A quantity that changes continuously with respect to time is AC. So that means power is of two types, AC and DC. So there is a need to convert either from AC to DC or DC to AC or AC to AC or DC to DC or DC to DC. So what is the meaning of this? We need to convert. If you are looking at the EDU, what are the main parts of the EDU? One is the source. Main parts of the EDU, one is the source. Another one is the switch. That is nothing but power converter or switch, power switch, let us say that. Next one is nothing but, what do we have, is a motor. In simple words, that's what we are looking at it, right? So now what we are telling is, this power switch, if they are modeled in such a way, let us say this motor, whatever the motor is there, let us say this motor is nothing but it is a DC motor and this source is DC, but the amount of power that it needs is not up to that level. Let us say that it has 5 volts and it needs 12 volts. So this is unmatched source but the type of source is same, but the magnitude is not matched. So you need to level up from 5 to 12. How can you do the change in voltage? Just now I showed you with a switch example what is happening over there. When Z is changing from 0 to infinity, the values of V and I are getting altered. So that means here the V has to change from 5 to 12 volts. So you need to model it through a power switch or a converter with multiple switches. It is called as power converter. Okay, power converter or power electronics converter. Okay, with multiple switches. So what happens is it can step up to 12 volts and it is nothing but DC to DC. So it will act as DC DC converter. So this is the basic idea behind that you need to understand. And maybe what if, if the motor is not at all, let us say that is DC motor, let's say it's AC motor. So here you look at the source is DC, moreover here the motor is AC. So you need to convert instead of this to AC. So there is a need for the conversion from DC to AC. That's why I said that DC to AC, AC to DC, AC to AC, DC to DC. Similarly, you can make your examples with various different types of sources. So this is just for understanding purpose. I have taken it. I hope you understood this, and let me give you a quick review of my slide, what it consists of, what did we just spoke about, what are the different power converters we have got. Let me give you a quick overview of this. You look at the overview. I feel that the overview is very, very important in terms of understanding the different converters that exist in electrical engineering in the form of power conversions. Or let's say that, what have we got? Let us look at it once. So now you see AC to DC converter. This is the one. You can see everything has one particular input and one particular output. Remember, in when we are dealing with electric vehicles, always remember everything has one particular input and one particular output. So you need to understand, if you say AC to DC, input is AC, right, and output is always DC. So you need to understand that. Similarly, we go for AC converters. Here input is AC, output is AC, but the difference is in terms of the magnitudes. Okay, either in terms of fixed frequency over here, variable frequency over there. So we will see where this can be employed in the EDU in the coming up lectures. But as if now you got to remember them. Okay, as if now you got to remember them. And the next one is DC to AC similarly, and finally DC to DC converters. Let me hide this for you so that you can see this. Yeah, so this is where the reference I have taken from. This is my reference book. I have a lot of references for you, so you can also go through. Now next thing is the electric motor generator set. So when we talk about the EDU, one of the major concern for our EDU is the motor generator set. What do you mean by motor generator set? So when you say a motor, when you talk about a motor, I told you that everything has one input and one particular output. And law of conservation of energy says that energy can neither be created nor be destroyed, but can be transformed from one form to another form. So what do I mean by that? Input is electrical energy, output is mechanical energy. But if you take another machine that is called as a generator, input, it also has one input, it also has one output. But generator has input as a mechanical energy and output as electrical energy. So what is the difference between these two? The difference between these two is they both are opposite. They are just like one side, two sides of the coin, where one side represents the motor, other side of the coin represents the generator. They're just like two sides of the coin, meaning they are interchanging their inputs and outputs. They are different in terms of their inputs and outputs, but the machine remains same. But the machine remains same. In fact, the technician doesn't knows when he opens whether it is a motor or a generator in general. So when you the way how you give the input to the machine, it behaves like that. So that there is one mechanism here in electrical drive units that is called as braking mechanism. So that is the reason people look at when the brakes are applied, some sort of energy should be stored in the battery. Okay, the braking energy must be stored back into the battery so that later on it can be used. So there is a need for electric motor generator set in EDU. We will talk about it. So this is just a basic understanding and explanation of that one. Now let us look at this. Yeah, I think, okay, I'm going to say that keep this. Look at this tire with a hub motor in it and with a gear mechanism. Oh, there's no hub motor, sorry. Let us look at this with a motor and a gearing mechanism with a tire. You can see that there is a motor over there. That's PMDC motor, permanent magnet DC motor. Okay, and this is something like a windmill. You can, I told you the other way around. If the wind energy is the rotating mechanical energy that applies as an input to the wings of the wind, then windmill, then the energy gets generated as electrical energy. There is a fan. You can take an example of your ceiling fan at home. This ceiling fan, the input is electrical energy and the output is a rotating mechanical energy. So it has electric motors inside it. This has a motor, this has a generator, this has a motor over here. So you can see that. So how things work in this, you can just have an overview of this. You can see there is a rotating mechanical energy over here. Due to wind, these wings are, this windmill is rotating. As a result, the input to this is mechanical energy and the output is the electrical energy. Here the motor is trying to rotate the wheel with the help of the gearing mechanism. Okay, let's move ahead. I think this is somewhat not coming proper. Anyways, here the motor with a gear mechanism and it goes with the wheel. Okay, so then you go to the next one. What are the different types of electric motors we have? There are different types of electric motors in electrical engineering. Since power is of two types, electric motors are also of two types, AC and DC motors. If you talk about AC motors, again they are further classified into these categories: asynchronous and synchronous motors, and also motor wheels. So let's look at them. What do you mean by asynchronous motors? When we talk about asynchronous motors, it is about basically the single phase and three phase, single phase, two phase and three phase motors. Basically single phase induction motor, two phase induction motor and three phase induction motors. So what do they have? If you talk about one phase, what is the main challenge in one phase is nothing but every motor has one stationary part that is called as stator, and it has also got one rotating part that is called as rotor. Okay, so there is one stator and there is one rotor. Okay, so there is one rotor. So motors have two different components. One is the stator, another one is the rotor. So stationary frame, the outer frame is called as stator. The rotating part is called as, this is a stator, and I have got one rotor inside this. So this rotor also carries some short circuited conductors in them. This also carries some short circuited conductors called as rotor conductors. If these rotor conductors are current carrying and they are under the influence of magnetic field, they tend to rotate. That means they allow rotor to rotate. As a result, the electrical energy from current carrying conductor to gets transformed to mechanical energy, rotating mechanical energy. Okay, so let's go to this diagrams. All I'm trying to tell you or show you over here is these are the rotors, the rotating component. You look at my cursor now, you see this is a rotor where it is rotating. Okay, it becomes rotatory in nature. So these are the three different aspects of different rotors. you can see that when they are rotating, why they are rotating is nothing but they are current carrying. The conductors are current carrying. There are some conductors on their periphery. Conductors means some wires and windings on their periphery. So they carry current and they are under the influence of magnetic field, north pole, south pole, north pole, south pole. Because of that influence of magnetic field, current carrying conductors always tend to rotate. This law is the Faraday's law. That is what is very very important, and the references has been listed over here for your review. Okay, so let me go to the next one. That is something called as, this is also one of the overview. You can look at the overview of the construction of a three-phase motor, how it is being constructed. This is what is the rotor I was talking about. One type of rotor called as squirrel cage rotor. We have different types, two types of rotors: squirrel cage rotor and slip ring rotor. Okay, so slip ring or phase wound rotor. Okay, so here we have squirrel cage rotor depiction. You can see that these are the slots. In these slots are the gaps the windings are placed, and this is the rotating field that is gets produced. So when this rotor is carrying current, rotor conductors are carrying current and they are under the influence of magnetic field, it tends to rotate. So that is what we can analyze, and this is how the current carrying conductors tends to rotate and electrical energy gets converted into the mechanical energy. Okay, so now go for let's say that if we have to analyze AC DC motors in depth, I have analyzed that in depth and I have tabulated some of the parameters, some of the most important parameters and their comparisons with respect to different motors that are used in electric drive unit, that are used as electric drive units. So some of them is nothing but the cost is the concern, torque, power density, efficiency, controllability, reliability, manufacturability, size, weight, robustness, wide speed range, fault tolerance, thermal limitations. All these are required. Like, you need to understand which is the best motor that you need to pick up for your application to design a best EDU, best performing EDU with less losses. So efficiency of course is one of the major concern. Efficiency is one of the major and an important concern. Of course the torque and power density play a role, with cost, because we all are Indians, so we understand that cost, torque, efficiency, size and weight is also important, along with the controllability factor. Most of them are the important factors that I've considered. So you can take a review. It's my own self assessment to the subject in terms of ACDC motors overview. So which motor is the best? I i i i want each and every one of you to analyze and understand that which motor is the best for your particular application. Okay, moving on forward, let me take the next step, a case study of DC-DC converter for electric vehicle. So if you look at, we are going to do a case study. Any topic, I strongly believe that can be understood mathematically, theoretically, practically, simulatively, and animatedly. So let us give an approach to this. Let us look at the EDU overview with a DC-DC converter. So you look at this. These are nothing but the sources. If you look at this, let me take another color so that I think I can make you people understand. This is the source battery. This is a switch. Okay, okay, with a DC link. We'll talk about it. What is a DC link? With a switching in between. This complete switching. This is the complete switching. Rather than taking it in this way, I would say that this has to be. Let me take an eraser first. So this is something related to the switches conversion. Okay, then there you go, the motor, electric motor with a transmission to the tires. So source, okay, power converters with switches, nothing but, and this is the motor. So I hope you understand the overview of the picture for the case study of an EDU. So what are we trying to do in this is we are going to control the speed of DC motor. Most of you have studied about speed control of DC motor using two methods. What are the two different methods? Flux control method and armature control method. So what is flux control method? N is the speed, phi is the flux. In flux control method, it is observed that speed is inversely proportional to the flux. That is nothing but, what are we trying to say here is, look at this diagram, basic diagram of your motor, electrical diagram of your motor. Basically it consists of an armature, a field winding with a voltage source. So this is nothing but your DC motor setup. This is your DC motor setup with a variable potentiometer, nothing but a variable resistance. Okay, so you can change this resistance. This is nothing but your DC shunt motor, or you just, this is nothing but your DC motor, simple DC motor. Okay, you just call this as simple DC. This is your DC motor. Okay, this is your battery or the source. This is your source. Okay, so now let's see what happens in this. Let's see what happens. Directly the source is connected to the motor of the same rating. So what happens is, you can, in this method, you can control its speed, okay, above the rated speed. Every motor has some rated speed. Let us say that this is the rated speed, which is 1500 rpm. What motor I'm considering is nothing but 1500 revolution per minute. Rpm means revolution per minute. DC motor, I'm considering that, and I'm giving an input to that, and I'm trying to vary this resistance so that the current gets varied, the flow of current is controlled in this circuit. As a result, I can control the speed above the rated speed. Why is that? When the current is getting, the flow of current through this flux winding, this is called as flux winding, can be altered, the flux can be altered. If resistance is maximum, the current is less, flux is less, speed is more. I'm considering the flux is proportionate to the current which is flowing from field winding. Okay, so that's nothing but, I'm just sticking on to that. And if the flux is less, the speed goes high. You can look at this and you can say that using this method you can control the speed above 1500 rpm. Okay, above certain limits you can go above, and you can control the speed of the motor above that. So this clearly says that the resistance is responsible for the change in speed. So remember, resistance or impedance, we spoke about a switch. Okay, either short circuited or open circuited, the resistance or the impedance is changed from 0 to infinity. So here, if this is replaced by a switching, this mechanism can lead to the speed control of the motor. So that is what I'm trying to link. I know it's a very different approach, my own way of understanding to the subject. I thought I shall discuss it with you in this manner so that you understand how things are controlled electrically. There is another method which is a converse method of the field control method, that is called as armature control method. Again, the same thing goes over here, but in this case the speed is controlled below. Okay, you can see that the speed is, let's say this line is of 1500 rpm, but speed goes below. So you can say that below 1500. So there is a motor again over here with a source. Okay, the position of, what is important to be noted is the position of the potentiometer or the variable resistor. Okay, that defines the action, either go below or above. Okay, so now let's look at the other aspect of the converters. Let's say DC-DC converters. So let's talk about a DC-DC converter. What is a DC-DC converter? If you look at a DC-DC converter, look at this diagram. On there are three different types of DC-DC converters. The first one is called as buck converter. Second one is called as boost converter. Third one is called as combination of buck and boost. Buck boost converter. So what is the meaning of buck? Buck means to reduce. Boost means to increase. Buck boost means reduce and increase. Okay, we'll take it like that, roughly from English words. These are non-technical words, but for understanding purpose, buck boost, we can take it as buck boost. So what is this regarding is nothing but, first one, what is a buck? How does it reduces the input voltage? What is the boost? How does it increases the voltage? What is the buck boost? How does it reduces and increases together? So let us see that. So what components, first let us talk about what components it consists of. It consists of a battery, you can see that a battery, a switch, okay, a diode, inductor, a filter capacitor, and the load of DC motor as a resistor. Okay, so DC motors, usually the load is being considered as resistor because they're DC in nature, right? DC means resistors. So you need to understand that DC means it's just a DC load, simple resistive load, nothing but a resistive load. So these are the components. I hope you have understood that. Now what happens over here is, what do you mean by buck concept? It converts DC to DC, but the issue over here is, let's say it has 5 volts, it reduces that across this output to 2 volts. So that means 5 got reduced to 2. This is a buck operation. Similarly, if you have 5 and it got changed between these two terminals, let us say the voltage that gets changed from 5 to 10, it is a step up. Step up, the value is increasing, step up. The value is decreasing, step down. Step down is buck, step up is boost. Then what if initially in one criteria it changes 5 to 2 volts, and in another criteria it changes 5 volts to 10 volts? Together it provides this operation. So that is something like buck boost converter. Okay, buck boost converter. So how does that happen is only because of the switch. Let us model this. You can model this, it's a very simple thing. Let's say that you have a voltage source. Okay, I'm not looking at it uh, as a MOSFET or IGBT. I'm looking at it as a simple switch. Then there is a diode, which is uncontrolled thing. Directly whatever gives it goes to that. Okay, there is a inductor, there is a capacitor, and it is connected to the resistor. I'm talking about buck converter. Okay, so if the switch is open, this part of the circuit, which part of the circuit? This part of the circuit is not connected at all. Switch is open, right? So that is not at all connected. So what does that mean? If it is not at all connected, that means that whatever current has to flow, the current will flow in this circuit. The current will flow in this circuit. An inductor is a type of an element that stores energy in the form of magnetic field. So whatever the energy is stored in this, that goes and circulates via diode to the load, which is resistor, comes over here. What happens if the switch is closed? Okay, what happens if the switch is closed? Look at the circuit very closely. What happens if the switch is closed? Okay, so now let's say that we just want to erase this, and let's say that what happens when the switch is closed. So what happens when the switch is closed? If you look at this aspect, if the switch is closed, this inductor gets charged and it provides the connectivity to the load back to the source, whereas this diode becomes reverse bias. Whereas this diode becomes reverse bias because current will flow from the source. Due to the source, the current starts flowing from here, and this diode cathode cannot accept the current here. It offers the blocking mode, and it goes straight. The current goes to the inductor and it charges. It goes to the load and it comes back to the source. So that is the path of the current. Okay, you will understand in detail when we are discussing about these concepts in much deeper aspects. How are we going to control the switch, and what time we are going to make it on, what time we are going to make it off? That is called as duty cycle. How are we going to model that? We will see that in detail, like how 5 volts can get converted into 2 volts. Okay, we'll see that. So now you look at, there's something called as the MATLAB simulation. There's something called as MATLAB simulation. If you go for a MATLAB simulation, the same thing, there is a switch. You can see here there is a switch, there's an inductor, there's a diode, there's a capacitor, there's a load R. So there is a source as a battery. So I have taken all of them and I have modeled it in the MATLAB. Okay, MATLAB simulating software, which is nothing but the buck mode of the converter. So I'm giving 100 volts, I'm getting 69. So 69 is lesser than 100. That means it is in which mode? Buck mode. Okay, this has been simulated. This is a simulation example. This has been simulated by me in the MATLAB, and I have modeled it in detail. So you can similarly go for the boost operation. You can look at this, 24 volts, and it got pumped up to 73. So the voltage got increased, and this is also being implemented in the simulation. First, initially we discussed the theory behind it. Now we are looking at the simulation model using MATLAB, and we also discussed the theory and theory about it, and the mathematics, 5 to 2, 2 to 5, or 10, 5 to 10. Okay, 5 to 2, 5 to 10. Okay, so also we need to look at this in the aspect of buck and boost together. So there are two scenarios over here. You can see that if you see 48, here we have only 4.5. 4.5 is lesser than 48, so it's buck scenario. Here 48, it goes up to 103, it is boost scenario. So that's why together it is called as buck boost converter. Okay, in simple words, buck boost converter. Now let's talk about the setup. What setup I have got? Always I look at the setups, like these are the batteries of 12 volts each. If you connect them in series, 12 plus 12 becomes 24 volts. Okay, it becomes 24 volts. Okay, and amps remains same. Let us say it has got 5 amps each. So 5 amps each will flow at the output. So 24 volts into 5 amps, because power is about voltage multiplied by current. So it is nothing but 5 4s are 20, 2, 1, 2. So it is nothing but 12, 120 volt ampere. That is nothing but 120 watts system. So the source is 120 watts. The motors should also be of 120 watts power. Otherwise, if they are not of that wattage, then we need to alter that using DC DC converters. I hope this is nothing but your switch, power switch. This is nothing but your source, which is nothing but battery. This is nothing but your motor. This makes your EDU. Simple, not just EDU, but simple EDU practically. I told you simulation, practical, theory, mathematical, and of course the animation. Okay, now let's look at one of the example over here. This is a bicycle. This bicycle, let me see if I can play this for you. Okay, so look at this cycle now. Here you look at the cycle now. Let us look at this practical example. Let's see this. See, look how beautifully you can drive or make a simple EDU to your bicycle. You can convert it into an electric cycle. So this is what it happens. See, the battery, the DC-DC converter, and simple DC motor can change your bicycle into a simple electric bicycle. So finally, I can say that we are born electric. We all are born electric. So we need to maintain that. And you can, of course, increase the load. That depends on the capacity of the motor and the design. So we may talk about those things in detail in the next lecture. So some of the career paths before we depart, are nothing but automobile industry, train locomotives, simulation and design industries, electric design engineers, power electronics engineers, battery management system. Okay, so this is Muhammad Imran, instructor at Great Learning, signing off. Thank you. See you.